Hello and welcome to this episode. Today we'll be discussing physics, an important topic which we call waves. This is where optics is covered, specifically light. But then, what are waves? Waves are energy or disturbances which travel from one point to the other without permanently displacing the particles of the medium. Now that looks like a big grammar, but if we were to explain it in plain terms, if you dip your hand in on the surface of still water, you will find ripples traveling outwards, but water still remains in the can. The water goes nowhere, but there is this energy you can feel moving, while water is just bouncing up and down. Same thing happens when when you twist the rope, when you swing rope up and down, you observe the rope remains with you, swinging up and down, but you find some wave traveling across the rope. So that is what we call wave. Most importantly is that it moves from the point where it is generated forward, but does not permanently displace the medium. The medium gets displaced only temporarily. So that's the definition of wave. Now, we can classify waves in two different ways. When you want to group waves, you can either do so according to their medium, or you can choose to classify them according to direction. Let me explain. When we classify waves according to medium, we are trying to say that there are waves which have the ability to travel from one point to another with or without a medium, whereas there are other waves that always require a medium for them to travel. For example, the light from the sun gets to the earth traveling through space, which we believe is mostly vacuum and has no gases, no material in between. So light is able to travel from the sun to the earth without needing any medium for its propagation. Now, any wave that does not require medium for its propagation is called electromagnetic wave, otherwise called EM waves, okay? While any wave that requires medium is called mechanical wave. So you see, the electromagnetic waves, otherwise called EM waves, are just 7 and must be remembered in the proper order. So the way to remember it is with the use of the acronym GXUV LIMR. GXUV LIMR. The G stands for gamma rays, X-rays, ultraviolet rays, light wave, infrared, microwave, and radio wave. These are the 7 electromagnetic waves. While the mechanical waves, which is those ones that require medium for propagation, examples are your light wave oftentimes also falls as a mechanical wave as well. It's both mechanical and electromagnetic. Then we also have the water wave. We have the wave on a spring, and so on and so forth. So there are countless, there are many other examples of mechanical waves. So next we'll talk about how then are they being classified when direction is the reference. Now, according to direction, waves are divided into the transverse waves and the longitudinal waves. What are transverse waves? Transverse waves are waves that when they travel, the medium vibrates in a direction that is perpendicular to their own. For example, if you dip your hand into water, water keeps bouncing up and down, but the wave is traveling forward. So what do you observe? You observe that the direction of propagation, the direction of vibration is quite 90 degrees to the direction in which the wave is traveling. Particle is vibrating up and down, but the ripples are spreading out. So a transverse wave has a waveform which we will draw like this. So for the transverse wave, we have this. This maximum magnitude of displacement is called amplitude. It's called what? The amplitude. And that's measuring from here down to this point. That's the amplitude. But this top, the point of maximum displacement, that's called the crest, while we have the point of minimum displacement, which is called the trough. While for longitudinal waves, there are waves that travel parallel to the direction of their medium. So if the wave is traveling forward, the medium as well is vibrating back and forth in that same direction. So they both form a 0-degree inclination. So waves that travel parallel to the vibration of the medium are called longitudinal waves. The most common example of longitudinal wave is sound energy or sound wave, while the transverse wave, all of the EM waves, all EM waves fall under the transverse wave, as well as the other waves like the water wave, the spring, and all that. They are all under the transverse wave. But longitudinal only has sound wave and wave on a slinky. At least those are the popular ones under longitudinal waves. And the waveform can be drawn like this. We just draw lines close to themselves, and then we have a little space out, and then we go closer to themselves again, and then we have space out. So these places where the lines of, or the wave lines are clustered together, represent the crest that we had for the transverse. This represents the areas where there was maximum displacement. So this is otherwise, now this region is now called not crest anymore, but compression, while the areas where there were gaps and spaces is called the rarefaction. So compressions are for longitudinal waves as much as crest is for transverse waves, and rarefactions are for longitudinal waves as much as trough is for transverse wave. And we've mentioned some examples. Now let's go into the wave equation. First we'll learn how to represent wave, and then we'll go into wave equation.